Okay, so this video is I'm gonna go over the even problems from the topic 2 quiz number 2 review, which covers factoring, sum and difference of cubes, and then synthetic division, long division, and the remainder theorem for polynomials. So for when I'm factoring in problems 1 and 2, I have a quadratic trinomial. So my first step is to identify A, B, and C. And so I've already done that. So A is the coefficient on x squared, or in this case, n squared, which is 2. And then B is the coefficient on the linear term, which is 13. And then 15 is C, the constant. And so the product, I'm multiplying A times C. So in this case, I'm multiplying 2 times 15. Which means we're looking for a product of 30 that adds to B, which is 13. Okay, so we're looking for two numbers that multiply to 30 and add to 13. And so right away, I can see that those numbers are 3 and 10. And so 3 times 10 is 30, and then 3 plus 10 equals 13. So remember that I'm finding those numbers so that I can split up the B term and use grouping to factor. So I'm going to rewrite the first term in the equation and then use my answer to my 3 and 10 to split up the 13. So I've got 2n squared. And then now I'm going to use 3n and 10n, both positive, instead of 13n, so that I can factor by grouping. And so then my constant term is plus 15. And so I'm going to factor these 4 terms by grouping, which means I'm going to take and split, if I can get my pen to change colors, I'm going to take and split this down the middle so that I have 2 terms on either side, and I'm going to factor out the common factor of each. Remember that I could have written the 10n first. That part doesn't matter. It'll just reverse the order of my factors that I get for this. So I'm looking at these 2 terms and I want to find what they have in common. So 2 and 3 have no common factors except for 1, and so that means I can just take out a variable. So since I have n squared and n, I can take out 1n. And then when I'm factoring, remember we're technically dividing. So if I divide each term by n, 2n squared divided by n is going to give us 2n. And then 3n divided by n is going to give us 3. And so remember the way that grouping works is that when I do this, I should get another 2n plus 3 when I factor the GCF out of the other 2 terms. And so the number that goes into both 10 and 15 is 5. Remember that whatever sign we had here always carries over. So if that was minus, it will carry down. And so always double check, just 5 times 2 makes 10n, and then 5 times 3 makes 15. And so I know that this worked because I now have this common binomial factor. So that now I have 2 terms that actually have a common factor of 2n plus 3. And so I know that that is one of the factors in my answer. And if I factor that out, my resulting binomial is n plus 5, the coefficients that I factored out in that step where I found the GCF of my grouped terms. And so that means that 2n plus 3 times n plus 5 is going to give us 2n squared plus 13n plus 15. Remember, when you take your quiz, it's a good idea to double check by multiplication so that you know that your answer is correct. For number 4, we have an x to the 4th power. And so remember that if I have an even power there, and that if the following term is half of that, that allows me to use the same product sum idea to factor this kind of trinomial. And so since there's no coefficient on x to the 4th, that means that a is 1. Same thing with x squared, so b is 1. And then finally, we have a constant of negative 20. And so looking at these, if I multiply a times c, it's just 1. So I get negative 20 for my product. And then the sum has to be 1. So I want to find 2 numbers that multiply together to make negative 20. So I know one's positive and one's negative. And then they have to add to be positive 1. So I know that the larger number needs to be positive. So 20's factors that work for that are 4 and negative 4 and positive 5, because negative 4 times positive 5 is negative 20, and then negative 4 plus 5 gives me 1. Remember that when I have an A as 1, this shortcut works with grouping, so it always works to be whatever power I have in the middle term, in this case x squared, and then it's just that term with the values I found from my product sum chart. So it's going to be x squared minus 4 times x squared plus 5. And so when we are factoring something that is not quadratic, but using the quadratic pattern, we have to look for difference of two squares within our answers, and then we do that because difference of two squares is factorable. So x squared minus 4 is a difference of two squares. Remember, that means that the factors here are x plus 2 times x minus 2. And so I can always factor that difference of two squares down to its linear factors. X squared plus 5, I'm not going to be able to find a number that multiplies to 5 and adds to 0. And so I'm really just looking for those difference of two squares in order to completely factor a quartic function. Okay, so that was factoring. After factoring on this review, we're going to go into long division. And so with long division, what we want to do is to first make sure everything's in standard form, and then identify if any terms are missing. So notice that our dividend has powers from 3, squared, linear, and then a constant. And so that's in standard form. So we can go ahead and write that down inside the division symbol. So we've got, I don't know why I just wrote a 2, we've got 6k to the third plus 4k squared minus 56k and then plus 24. And then our divisor, 6k minus 2, is also in standard form, so we're going to place that on the outside. So remember that as we're doing long division, we are looking at just the first term in each piece and identifying what number I need to multiply 6k by to get 6k cubed, or think about it as dividing 6k cubed by 6k. And so I need to multiply this by a k squared. And then remember, what we do is we actually multiply times each of the terms as we write it underneath. So I'm going to multiply k squared times 6k, which gives me the 6k to the third power I was looking for. And then when I multiply minus 2 times k squared, that's going to give me a minus 2k squared that I'm going to subtract from the next term. And so remember that we're subtracting these. And so 6k cubed minus 6k cubed goes away, which was the whole point of this. And then 4k squared minus 2k squared is going to give us 6k squared. Sorry, I said that wrong. 4k squared minus negative 2k squared, right? So this turns this negative and that positive if we distribute through that negative. And so we get a positive 6k squared, and then we want to bring down the 56k term for the next step. So again, we're just looking at the first term in both pieces. So in the dividend and the divisor. So we're looking at, what do I need to multiply 6k by to make 6k squared, which is just a k. So I'm going to put plus k at the top. And then I'm going to multiply k times 6k, which gives me that 6k squared I was looking for. And then also k times negative 2 gives me minus 2k. And I'm going to subtract those two things. And so remember, when we subtract, we're really changing the signs of both of these terms. And so the whole point of that is so that this disappears, right? That cancels to 0. And then we have negative 56k plus 2k is going to give us negative 54k. 4k, and then we're going to bring down the plus 24. Okay, so in what looks like it's our last iteration of this, we're next looking, because I have 2 terms here and I have 2 terms here, so I know that I should be done, because once this is a lower degree than my divisor, then I know that that value is my remainder. So I'm looking at 6k and negative 54k. And so I know that 6 times 9 is going to give us 54, so that means we need negative 9. And so if I multiply negative 9 times 6k, I get negative 54k. And then negative 9 times negative 2 is going to give us plus 18. And then remember that we're subtracting these things. And so if I subtract, I'm making this a minus and this a plus so that it cancels. And so then we're going to have 24 minus 18, which is giving us 6. So again, I know that it's the remainder because this is a constant, and then our divisor is linear. So that means that our answer is k squared plus k minus 9 with a remainder of 6, or k squared plus k minus 9 plus 6 over our divisor 6k minus 2. Okay, so either one of those is an appropriate answer. On the next page, number 8 is asking us to divide using synthetic division. And so just like we did with long division, we want to look at our terms and make sure that A, it's in standard form, and B, there is no missing terms. And so 9a to the 4th power means that we should have a 3rd power and then a 2nd power. And so since we're missing a 2nd power, we're going to kind of insert a plus 0 x squared, just so we remember that if we miss those coefficients on synthetic division, our answer will be wrong. And then we have a 1st power and a constant. So the rest is good. So that means that when we put in our coefficients from our dividend here, we're going to put 9, and then 54, and then 0, negative 10, and negative 69. The value that we put in the box on the outside, remember, is our divisor, the 0 of our divisor. So if I have a plus 6 equals 0, that means that a equals negative 6. And so we're going to use negative 6 in our synthetic division. Okay, so we're going to bring down the 9. So negative 6 times 9 is already negative 54. And so that's going to give us 0. Then when I multiply by 6, we're still going to have 0. When we add to 0, we still have 0. Multiply times negative 6, and we got 0. And so then now we're finally going to get a value. So that gives us negative 10 times 6 is 60, which means that we have a remainder of negative 9. Okay, so just a reminder, we multiply the bottom number by the negative 6 to place it underneath the next term. We add vertically and then repeat the process. So negative 6 times 0 is still 0, then 0 plus 0 is 0. Negative 6 times 0 is still 0, and then negative 10 plus 0 is negative 10. Okay, so then negative 6 times negative 10 gave us 60. And so remember that when I am identifying my answer, because I divided a to the 4th by a, that means my first term is a cubed. And then my second term is a squared, and then a. So that means that this result is 9a cubed, and then minus 10 plus a remainder of negative 9 over x plus 6. Okay, so then for number 10, they're asking us to identify the remainder of each. And so the remainder, remember, is essentially it's what's left over when we do synthetic division, right? So it's this -9 would be the remainder of the first problem. So we can use synthetic division to find the remainder. The remainder theorem states that what I can do instead is plug in the 0. So if I'm looking at this, if I were plugging into the equation, the 0 of this would be x equals 1. Okay, so if I plug 1 into the equation, that'll give me the value for the 0. And so 1 to the 4th minus 1 to the 3rd minus 3 times 1 plus 13. Okay, so that gives me 1 minus 1 minus 3 plus 13. Okay, which 1 minus 1 cancels, and then negative 3 plus 13 gives us a remainder of 10. Okay, so we can either plug the value in, or we could have done synthetic division. So I'm just going to show the synthetic division as well. Notice this one's also missing an x squared term. So I would put that 1 over on the side. So the 0 in my divisor is the number that I'm using for that multiplication piece. I'm going to list my coefficients. So I have 1x to the 4th minus 1x cubed plus 0x squared minus 3x, and then plus 13. So that I know my remainder is going to be underneath the 13. So if I bring down the 1, 1 times 1 is 1, and then negative 1 plus 1 is 0. 1 times 0 is 0, 0 plus 0 is 0. 1 times 0 is 0, negative 3 plus 0 is negative 3, and then 1 times negative 3 is negative 3, which gives us a remainder of 10. So again, either way, you get the value for 10. So whatever you're more comfortable with, you're either plugging in the number, doing synthetic division and finding the remainder, or maybe doing both to make sure that your answer is correct. The final concept that is on quiz number 2 is the sum and difference of cubes. So I'm going to do the difference of cubes problem. Remember, the only difference between the sum problem is the signs, and we gave you that acronym SOAP to remember how it works. And so ultimately, when I do this, if I have a difference of cubes, I know my answer is going to be a binomial with the same sign in between. Okay, that's what the S stands for, is same sign. Then it's going to be a trinomial where I have the opposite sign, and then something that is always positive. So what I have to do is first figure out what these values are, and then remember how they work together. So 216 is 6 cubed. And then within each of these, I have, this is going to be a 6. And then the trinomial starts with that number squared. And the next term is going to be the product of the two pieces. So I'm going to put this one in parentheses here. And so then 125x cubed is 5x all cubed. So 5 cubed is 125, and then x cubed is x cubed is x cubed. So the second term in that binomial is that 5x. And then the middle term in the trinomial is that 6 times 5x. And then the last term is that 5x squared. Okay, so remember that when you're doing 11, the only difference here is that the signs change except for the last one. So it's plus in between, which means it's plus here because those have to match. And then this one's always the opposite. So it's like those two will switch. So what we have to do for our answer is simplify. And so the binomial is always the same. So it's just 6 minus 5x. And then we want to simplify the trinomial. So 6 squared is 36. And then 6 times 5x is 30x, so plus 30x. And then 5x squared, remember we're squaring the whole thing, so 5x times 5x is 25x squared. And so that's a difference of cubes factorization. So make sure that you know the setup of them and that acronym SOAP, the same, opposite, always positive. Okay, so that's what the quiz will look like for topic 2. Remember that all the questions are multiple choice except for the problems like number 6, 5, and 6, so long division. And then also like 3 and 4, the factoring when you have a quartic trinomial. So make sure that you're kind of practicing and thinking about how those questions can be asked.